At Ingesert in the morning, an invisible shield around Earth suddenly vanished. The planet's magnetic field dropped to nearly zero. Nothing exploded. The sky didn't change color. But one of Earth's most important protections was suddenly gone. The magnetic field normally stretches far into space, deflecting charged particles streaming from the sun. Without, Earth was suddenly exposed to a constant storm of solar radiation. The first signs appeared in orbit. Satellites began experiencing interference as energetic particles slammed into their electronics. Navigation systems flickered. Communication links grew unstable. Some satellites shut down completely to avoid damage. On the ground, compass needles began spinning unpredictably, no longer pulled toward a magnetic north. For animals that rely on Earth's magnetic field to navigate, the world became instantly confusing. Migrating birds changed direction mid-flight. Sea turtles near coastlines circled aimlessly in unfamiliar patterns. High above, astronauts aboard space stations moved into shielded areas as radiation levels climbed. Airlines rerouted long-distance flights away from polar regions where radiation exposure would now be much higher. Passengers on those flights never saw the danger, but invisible particles were passing through the aircraft walls. Power grids began to feel the strain next. Solar radiation triggered electrical currents in long transmission lines. Transformers overheated. Some regions experienced sudden blackouts as protective systems shut everything down. In the night sky, something beautiful and terrifying appeared. Auroras, normally limited to polar regions, spread across the globe in shimmering curtains of green and red light. Cities far from the poles watched glowing waves dance overhead, unaware that the display came from dangerous radiation. Over time, increased radiation at high altitudes raised health risks for pilots and frequent flyers. Electronics became more vulnerable. Tiny errors in computer chips appeared more often as particles passed through them. Space agencies powered down sensitive instruments, trying to protect spacecraft from long-term damage. The atmosphere itself provided some protection, absorbing much of the incoming radiation before it reached the surface. But over months and years, higher radiation levels could slowly affect living cells, increasing mutation rates. Scientists would rush to understand what caused the collapse, studying Earth's core where the magnetic field is generated. The field comes from swirling liquid iron deep beneath the surface, moving like a giant hidden dynamo. If that motion changed, the magnetic field could weaken, shift, or even reverse over long periods of time. But a sudden disappearance would be unlike anything humans have ever experienced. Technology would have to adapt with stronger shielding for satellites, aircraft, and power systems. Life on Earth would still be possible, but the planet would be far less protected from the sun's constant energy. The magnetic field is visible, silent, and easy to forget, yet it quietly guards the world every second. And if that shield ever failed, the sky itself would remind us how exposed our planet truly is.